Welcome everyone, I'm Eric Durand. I'm a product leader for our hybrid cloud services here at AWS, and I spend most of my time working on AWS Outposts. I'm very excited to be here today to talk about delivering low latency applications at the edge. I've actually been working on AWS hybrid services since they began initially at AWS. And I've been here to watch the journey since we've launched services like Outposts and Local Zones back in 2019. And I've seen all the features and innovation that we've delivered over those years, as well as see our presence expand globally. I'm joined by Pranav Chakra, who is our principal product manager at AWS, and he focuses on local zones. So for our agenda today, we're going to spend some time talking about low latency use cases, and then we'll do a deep dive first on Outposts and then later on local zones, and talk about how customers are using these two different hybrid edge services to meet the low latency needs for their customers. At the end, we aren't going to be able to do Q&A, but we can meet you outside if you have any questions, and happy to take questions out there. So we've seen a wide adoption across industries for our AWS hybrid offerings. Customers from multiple sectors use AWS hybrid services for various use cases. So for example, if you look on the left side of the slide, you'll see that we have customers that are, on the right side of the slide, that are migrating and modernizing their enterprise workloads. This can include back office applications, moving to software as a service. And in doing these migrations, hybrid services can be useful because they're dealing with the challenge of just the size of the migration itself, interdependencies with on-premise infrastructure and data, and other constraints that can really slow the migration. So hybrid services can help ease that along. And then on the left side of the slide, you'll see that the low latency workloads is the topic we're going to focus on today. And examples of this include real-time medical imaging, content creation, and media streaming. And because it's low latency, really the key requirement here is fast response times for your end users. And then in the middle, I kind of group these two together to think about them as data locality. And this is examples where customers use hybrid services because data needs to stay in a particular location. So some of the data can't go to the region. And so that could be due to regulatory needs, security, or just that there's a need to do local data processing. So the way we think about our hybrid services is customers have told us that they want a consistent experience. They want the same experience at the edge as they do when they're working in the AWS region. And so this includes providing a consistent set of APIs and consistent services. Also, you want to be able to use the same automation tools, whether you're building your applications in the cloud or building them for the edge. You want to use the same security controls so you can have a uniform security policy no matter where your applications are being deployed or where your data is stored. And finally, you want a consistent operational experience, whether that's at the edge or in the region. And so what hybrid edge services at AWS allow customers to do is it really allows them to accelerate their innovation because they can focus on delivering the application wherever it needs to be. It also allows you to manage that same, manage a global deployment with a consistent set of tools and a consistent set of skills. And then finally, it allows you to adopt a cloud security posture anywhere your application is deployed. So let's focus in on just low latency use cases. As I mentioned, we see hybrid cloud services across a number of industries, and we also see low latency use cases across a number of industries. It's one of the main drivers of the use for hybrid cloud services. So these really, the needs here are just driving that real-time access for end users. The applications need minimal delays to ensure a responsive experience for your end customer, your end user. And some systems even require single-digit latency or even sub-millisecond latency in some cases. So examples of these, as you can see on the screen, are in multiplayer gaming, where you need to measure your latency in tens of milliseconds, or in things like financial exchanges and core trading systems, those need to be running in sub-millisecond latencies. So in real-time multiplayer gaming, you see companies like Riot, Epic, and Supercell. They deploy game servers all over the world to bring the application closer to their end user, to the gamer. And so as a gamer, right, lag negatively impacts your experience. It doesn't make your game feel real time. And so the ideal latency in this scenario is between 20 and 40 milliseconds. And really the only way to accomplish that due to the speed of light is to bring that infrastructure closer to the gamer. And so what these gaming companies do is they deploy latency-sensitive game servers all around the world in multiple locations so that they can ensure a real-time and interactive gaming session for their customers. In the media and entertainment industry, companies like Netflix run expensive artist workstations in specific locations, where their talent is, like Los Angeles, so that they can perform video editing and do live production. And so the key latency requirement here is they need to have a jitter-free experience for managing and manipulating that content. And so specifically on those remote end workstations. And so the latency threshold for this type of use case is sub 5 milliseconds from their offices or from the animation hubs to the artist workstations. So again, very difficult to do that in the region, and the need there is for hybrid cloud services. In the financial services industry, companies like NASDAQ run financial exchanges in key metros like New York City. And again, here we talked about this is an ultra low latency use case. They need to have sub-millisecond latencies for real-time data gestion and distribution, for handling that marketing data and those trading systems. In healthcare and life sciences, they have a need for low latency compute. Healthcare customers rely on management software to support things like radiology practices, their health systems, or even clinical research. And so in the imaging use case, radiologists use rapid low latency access to high quality images in order to do a diagnosis for a patient. And so with the low latency, it ensures that radiologists can focus on improving patient outcomes without worrying about system performance. And then finally, the final low latency use case we'll look at is just challenges as an enterprise migration. And this one might not jump out of you as a low latency use case, but what we've seen with our hybrid cloud services is that many customers have interdependent systems in their existing on-premises data centers, things like mainframes, legacy data warehouses, large amounts of storage, or large amounts of data sets on existing storage. And so what customers do is you can't provision your new applications necessarily fully in the region. You need to bring the region to those data sources and have a hybrid environment. And that allows you to connect to those legacy data sets locally and over time perform a migration to move the application when you're able to. So I've mentioned the hybrid services, so let's talk a little bit about what those are. So we have an entire cloud continuum of services, and those range from the region, which I hope everyone is probably familiar with, out to these distributed locations. So as we work out from the region, you have local zones. And so local zones are deployed in major metropolitan areas or in large industrial centers. And we're growing that footprint all the time, and Pranav's gonna talk about that. We also have wavelength zones. And what wavelength zones is bringing AWS compute and services into 5G core network locations to improve the ability to process mobile applications. Then we move to on-premises, the world that I spend most of my time on, and that's where we have AWS Outposts. And what AWS Outposts allows you to do is to extend the region, and extend AWS infrastructure either to your co-location facility or to your premises. In this scenario, we also have what we call dedicated local zones. So dedicated local zones are local zones that are fully managed environments that are deployed for a specific customer at a customer-specified location. And then we have solutions that allow you to run on both AWS managed offerings and off of AWS managed hardware on, say, third-party commodity hardware. And that's where we have the Elastic Container Service Anywhere, ECS Anywhere, and the Elastic Kubernetes Service, EKS Anywhere. And these will allow you to integrate your container environments on any hardware with AWS. And then finally, we have out at the far edge, we have solutions like AWS Snowball, which this allows you to extend cloud computing capabilities out to remote rugged locations where you have limited or perhaps never even have connectivity. So let's talk about extending AWS services on-premises, specifically with AWS Outposts. And so as I mentioned, Outposts extends the AWS infrastructure, including EC2 and a select set of services directly into your on-premises environment. And that doesn't have to be a data center or a co-location facility. That can also be things like an IT closet, a back office, a factory work floor, and we'll talk about kind of the different form factors that enable that. The first form, these are the form factors. And so this is what we refer to as the Outpost family. And there's two hardware architectures for Outposts. There's a full 42U rack, industry standard size racks that you would find in a data center. And then there's two different server form factors, both a 1U server form factor and a 2U form factor. And so the 42U rack, this is the same hardware, the same rack that we use in our regions, in our own data centers. And the rack itself is managed entirely by AWS. And the way you should think about this rack is this is the smallest piece of region hardware that you can get on premises. This matches what we do in the region. And really the customer responsibility when taking one of these racks is you provide the power, you provide the space, and you provide the network connectivity, and we do the rest. And then with the 1U and 2U server form factors, these give you smaller, more flexible deployment options, and that's what I was alluding to earlier, right? These server form factors don't even necessarily require a rack, right? You can mount them in a back office, you can mount them in an IT closet, in many different locations or on a factory floor. And this really is just for any locations, if you think about it, where a 42U rack can't fit, but you still want to extend EC2, right? You want to extend the ability to run with a consistent set of APIs. And so you might just need one or two of these servers. You might need 3 or 4 of them. You might manage whole fleets of them. We do recommend, as it pertains to the servers, that if we're running a business critical application, we should always be running 2 for high availability. And so before I move on, I wanted to take a minute to thank all of our existing Outpost customers and our Outpost partners. And these range, as mentioned, all these industries we've been talking about. Customers in financial services, in gaming, in manufacturing, communications and telco space, as well as in the public sector. And so these customers are leveraging Outposts to leverage EC2 on premises for these use cases that we're talking about, including low latency. And this enables them to create and have a truly consistent and secure experience across no matter what environment they're deploying in. And what that does is that creates efficiencies for both developers and operators, right? It's the same, I can develop once and I can deploy it where I need. I know how to operate it regardless of where it is, whether it's in the region or at the edge. What it also allows you to do these customers to do is to accelerate their innovation, because they can focus on developing their application, right? And less about managing their hardware. And then finally, we have a number of partners, some of who are included in this slide, that help customers work to accomplish this, to modernize their on-premises infrastructure, modernize their applications, and to provide some of the best support in the industry. So, as I mentioned, we launched Outposts back in 2019, and since that time, we've been very busy expanding the services, expanding availability of the service around the world. Today, Outpost is available, both racks and servers are available in over 75 countries and territories around the world. And the way we think about this is we've did this in a few different phases. When we first started the service, this list was not nearly as long, and we were able to ship Outposts and deploy Outposts into countries and territories where we were already doing business, where AWS was a known quantity. And then what we've been doing the last several years is really what I consider our second phase of expansion. And that's gone rather quickly, but what we've deployed quite a bit, but what that's entailed is we've had to set up business entities, we've had to set up shipping depots, we've had to create new logistics capabilities for going and being able to deploy in all of these new locations and meet certain regulatory requirements. And now I would say we're closer to our third phase, which is more of the long tail of countries, right? And what drives that priority, and that we will continue to do that, but what drives our prioritization of that expansion is feedback from customers. So customers tell us all the time, this is where I need Outposts. We do take that data in, we talk about it all the time, I work with my team on it, and we will constantly work to expand that. So if you see a country that we don't have Outposts available and you need it, let your AWS account manager know, tell me when outside of here, right? And we want that data so we know where to go next. So AWS Outpost brings EC2 on premises is the way I like to think about it. It also brings other services, but at its simplest element, it allows you to leverage EC2 on premises. And what this does is it gives you that flexibility in deployment. that consistent experience across being in the cloud and being on premises using the same APIs, the same tools, and the same services, at least a select set of them, that you're using in the region. The consistency in development, as I mentioned, this allows developers to use that same set of tools and APIs. There's no need for separate training for managing what you had on premises because it's a different environment. It's the same skill set that you're using in the cloud. It also gets you out of the business of that undifferentiated heavy lifting of infrastructure management, right? So this is a fully managed offering. We are managing the hardware. We're responsible for ensuring that that hardware stays up and running. You can think about this as, it also, with our hybrid services, we employ the same shared responsibility model with some addition. So with Outposts, the customer is responsible for providing physical space, providing power, providing network connectivity, and then we manage all the hardware and infrastructure. We manage every outpost like it's an extension of our regional fleet. We send personnel on site, we replace hardware when needed, we do all the break fix. And then last but not least, you have a single pane of management. So Outposts are completely configured and managed from the AWS console. So the same console you use to deploy services in region is the same console you use to manage each and every outpost, whether that's a rack or a server. That also lets you use the same tools to manage this infrastructure. So things like CloudTrail and CloudWatch, any other network alarming type services that you would set up in the region, you do the same with your Outpost. So as I mentioned, this simplifies your IT management complexity for customers. This amplifies your developer productivity, and it allows for faster development cycles, and it allows your on-prem applications and infrastructure to move at the pace of the cloud. And really, this just takes a cloud-first mentality on-premise and allows you to focus your resources on differentiating your business through application development and not through infrastructure management. So let's go a little deeper on the rack. So as I showed the picture of earlier, this is the rack. This is a standard 42U rack. It fits into most data centers, although it is quite large and quite heavy. So we do actually, when we deploy these, we send an advanced team on site to come out and ensure that you have the correct power, you have the correct space, and you have the correct weighted floor requirements. If you look at this rack, a fully loaded rack here weighs about 1,700 pounds. And it's shipped, and we make these to order. When customers order them, we make them in our manufacturing facility. We ship it in a secure crate that actually has tamper-resistant or tamper-evident enclosure, and so that we can ensure that it's been securely shipped. And once it's been shipped to you, we deliver that on site, and we install it on site at your location. So many considerations when we're doing that. That's why we come out and look in advance, because we found out all sorts of surprises in people's environments and their data centers when trying to bring these racks in. The rack has been designed with redundancy in mind. So there's really a minimum of 2 of every component. We have redundant power. We have redundant networking switches. We have redundant network connectivity. At least 2 of everything. The only thing that there isn't necessarily 2 of, although I would highly recommend it, is the compute servers that are within the rack, because those are configured by the customer. So what we do is we would work with you to determine what are the instance types you need, what are the compute workloads you're running, what is the storage capacity you need, and then we populate the rack with the correct amount of servers and the right size servers. And then we are constantly monitoring this rack, like I said, as an extension of our regional fleet to ensure the uptime and reliability of the rack. So the rack, if you see, so it's top of rack switches. It can support 110, 40, and 100 gig network fiber for uplink. It has dual network switches, as I mentioned. And then in terms of power, this thing, depending on how you populate it, can use quite a bit of power. So it uses, it comes with 2 5 to 15 kVA power supplies. And what we recommend is those power supplies need to be connected to distinct separate power sources, right, for maximum reliability and uptime. So either if you have 2 distinct power feeds in your co-location facility, your data center, or one of those is to a feed, one of those is to a backup generator, that's the things that will work with you when we are bringing this to deploy it, or when we're speccing it out to deploy. We have dual network connections coming out of the outpost for uplink into your environment. And we also recommend those go to distinct networks, right? Most co-location facilities offer a myriad of options. The one thing you want to avoid is you don't want this coming back to some piece of fiber up the road where that gets cut by a backhoe and now the redundancy was for naught. And then, as I mentioned, it's customizable compute. So you choose the amount of compute that you need based on your needs. And then we recommend that you plan for extra capacity. So you never know if you have a bursty workload or you expand use of the service and you want to have some of that capacity in there. Because we're doing this on premises, we do have to do a bit of capacity management. And then we'll work with you to balance out what are those compute needs, all the space, power, and all of these requirements, and understand and make that match your business requirements. So the rack architecture, it's really an extension of the AWS region. So we extend your infrastructure to on-premises. Outpost resources appear as a private subnet within your VPC, and it's connected to a home region. So every outpost anchors back to a specific home region that you're managing it from, just like you would manage other resources out of that home region. And then it's managed by the regional control plane in that region. And that's what it allows to have a seamless integration with either across multiple availability zones or even, as Pranav's going to talk about, even with other local zones that are anchored to that same region. And what Outposts introduced different than the region is two new logical networking constructs. So one is the local gateway. And so as that indicates, right, that is the logical connection that provides connectivity into your local infrastructure. And so that could be other infrastructure in your data center. It could be third-party storage. It could be other systems it's going to access. It can also be the internet connection out of the co-location facility. The other logical construct is a service link. And so the service link you can think of as like a site-to-site VPN, and that's where all the managed traffic goes across from the outpost back to the AWS region. That includes when we first provision the outpost, we're provisioning it over that service link. When we are later, when you are adding new AMIs to that outpost or new services to that outpost, some of that service traffic is traversing that service link. And then we're using a piece of that, if you will, a small amount of that for all the management and monitoring of the actual outpost itself. So I've mentioned EC2 a lot. Let's talk about the other services that are also available on Outposts. And so we offer the same tools and services that are in the region, as I've mentioned. And what that does is that allows that seamless development and that seamless operational model, both from on-prem and on cloud. And as you can see, we have about a dozen services that are available locally on the Outpost. And of course, the Outpost, as it's connected to the region, can also leverage, and your applications can leverage services that are in the region where that makes sense. The things you want to think about there is if I'm architecting an application for data residency, I want to ensure that the services that I'm using, the storage services, for example, that I'm using, where I'm storing my data, are local to the Outpost. I don't want to store that data that has, regulatory implications on anywhere but the Outpost. I don't want to bring that back to the region. The other consideration is, like, if we're architecting for low latency, as we're talking about today, then I need to be thinking about, like, what are the services that I need that are in the direct path of my end customer so I can ensure the fastest response time. I need to use those services that are local to the Outpost, right, to avoid things. But perhaps I say I want to use a Lambda function on the back end that doesn't directly impact my user for some data transformation. I can do that, and that can still be used back in the region. So we do have a number of core compute services. So I've obviously mentioned EC2. We have EBS. We have a local version of S3 on the Outposts. I'm not going to mention them all. We have a Route 53 local resolver. And then we have things like container services, of course, ECS and EKS. And then database with RDS. We also have EMR. Any number of services you see. And then again, you can extend back to the region. One other consideration that I don't have on this slide is in some cases where we don't have a service that's local to the Outposts, there's a number of different Amazon Partner Network solutions, APN partners out there, ISVs, that have built API-consistent offering software that you could run on the Outpost that still enables you to architect your application to be completely consistent with the deployment in the region. It's just going to leverage that third-party component when you're doing that on-prem, if that's your need, and you'll still be able to pull that back with that same consistent API experience into the region when that makes sense. So let's then look at the servers. So the servers are quite a bit smaller, a bit more flexible. And this is a newer offering. We came out with this a few years back, and it's still a space we're very, very excited about. We're seeing a lot of traction in. And so the 2U server is based on Intel processors, and the 1U server is built on Graviton processors. And when we launched the 1U server, this was actually the first time you were able to get Graviton outside of an AWS data center. And so what the servers have, they use significantly less power than the racks, as you can see. They use 1 to 2 kVA, and they use standard AC power. So what typically you would already find in virtually any rack or pretty much in any environment, so that you could just plug these in and use them. They have a 10 gig uplink. It also down selects to 1 gig, so you can run it at 10 or 1 gig. And then the other different construct here, which I'll talk about in a minute too, is this doesn't have the local gateway, because it's a single server, right? We have a local gateway on the rack because it has multiple servers, it has multiple switches. In this case, we just have what we call the LNI, the local network interface. And this is just a layer 2 connection to your local network. And it's where traffic is all going to traverse. These all, so you'd be putting these into your own switch, right? So you'd be managing the network in this case. And you would be, traffic between redundant servers would traverse your local network at layer 2. And then this also then leverages the service link, right, which is that same logical connection back to the region. So Outpost servers use the same logical constructs as Outpost racks. It's consistent across both. EC2 instances are hosted in a private subnet and within the home region, just like with the racks. And you have flexibility with your VPC. Your VPC can span multiple availability zones. This can include Outpost servers and Outpost racks. For high availability, right, that's what I mentioned before about sort of a minimum of 2 Outpost servers when you're deploying them, if high availability is a concern, which it is with most workloads. Each server has a unique Outpost ID, and so what this enables you is to configure your application for fault tolerance to fail between the unique Outpost servers, or almost like acting as separate instances. You can also then, we've seen, as alluded to the bottom, we have some customers that are deploying whole fleets of these servers in manufacturing use cases. And in this use case, they use CloudFormation templates to sort of rubber stamp out their standard configurations for deploying these servers, which allows them to expedite their deployments. So the local network interface, as I mentioned, it's a layer 2 connectivity. It provided directly into your switch, and this is direct communication between your on-premises resources and the Outpost server. The service link will traverse this physical link, but that's a site-to-site tunnel back to the region, just like the rack, with that metadata, with that provisioning software when you're first deploying the server, and then it's the connection by which you're getting back to the region to use additional services over that service link. So we see customers using these in factories, in smart retail store components, as I mentioned, in manufacturing. And we even have customers who use these for experimentation, right, in their labs. We have a lot of AWS employees that are using these for experimentation in their own labs as well. So I want to talk about a few new announcements that we made. Just one right on reInvent on Sunday, this one, and then I'll talk about the next one. So I'm super excited about these, and I'll talk about the implications of them. So we have a new feature, and it's the first of more to come, but this is where we are simplifying the use of third-party block storage with AWS Outposts. And so what this means is for customers that have your on-premise data center, you've likely already made an investment in on-premises storage. So our launch partners for this are NetApp and Pure Storage. And what we've done is you're now able to attach to block data volumes that are configured on a NetApp array, or on a NetApp filer, on a Pure Storage array. You're able to connect those block data volumes to your EC2 instances hosted on the Outpost rack or the Outpost server. So what this allows you to do is to take advantage of the storage you've already invested in, gives you additional capacity if you already have it there, or if it makes sense for you to deploy more. And it allows you to take advantage of frankly, the things that these storage vendors do very well, is they've been managing on-premises storage for a long time. They do things like thin provisioning and deduplication and different things with snapshotting. all sorts of advanced data management capabilities. And so with these partnerships, and as we continue to expand our partnerships, we'll continue our deeper integration with our storage partners to give you more flexible deployment options on premises. The other piece, and this is very critical in low latency applications as well, is, as I mentioned, the Outpost is a connected service, right? So we have that service link back to the region, and that's how you're managing the Outpost. And so that requires connectivity to the region if you want to make any mutable changes to your instances or configuration changes to your Outpost. And so we announced just a couple weeks back our first iteration of static stability for EC2 instances on Outposts. So what this means is that you can have a loss of network connectivity. You can have the Outpost rack or the Outpost server be power cycled, and your instances that were already running will continue to run in the event of loss of power, whatever state those are in. So if your instance was running, it will come back up automatically and continue operating. So if you have a business critical application, you lose network, you lose power, you now have a higher resiliency than you did previous to this announcement. This, today the guidance we're giving and the testing we've done is we support periods of connection up to 7 days. We're going to continue to work on that. We're going to continue to do more testing. We've certainly seen customers who have done more, but that's what we're stating based on what we validated with our engineering. The other thing to think about this and the previous announcement is when you're architecting applications these low latency applications that need to be persistent on premises, regardless of power outages or connectivity losses in particular, is if you take the third-party storage integration piece, you'll be in a place where you can now leverage the boot volumes off of your third-party storage array, which has always been designed to operate disconnected, right? That's from a pre-cloud world. And now with the static stability for EC2 instances, you can architect your application to be have persistent compute and persistent storage through any network outages. So I'm going to wrap up before I hand over to Pranav with a few customer use cases. So Mercado Libre is one of Latin America's leading e-commerce platforms, and they needed to optimize their distribution center operations while maintaining to their strict low latency requirements for their operational technology, their OT systems that were on premise in their distribution centers. And so they did this by deploying AWS Outpost racks to enhance their existing infrastructure in their distribution centers. And then they integrated the automation systems to streamline their warehouse operations and improve their overall efficiency. Since they had the Outpost there, they then migrated over their physical access controls, they moved over their Wi-Fi access point controls, and all of that's now being hosted on the Outposts in these distribution centers. They've also been in the process of testing robotic control services on Outpost servers, and so that they're going to be able to extend their Outpost fleet out to more points to just build more efficiency into their overall operations. And what this did enable them to do was to achieve their goals for single-digit millisecond latency and improve the real-time responsiveness for their critical workloads in these distribution centers and in their service centers. What it's also allowed them to do is have a more consistent management experience across all of these different locations. The next one I'll talk about is Vector Limited. So Vector is New Zealand's largest distributor of electricity and gas in New Zealand, pardon me. They serve about 30% of the overall population of New Zealand and represent about a third of the nation's GDP. And so they're running they manage their electricity distribution network with a system called GE Advanced Distribution Management System, or GE ADMS. And so this is a business critical national infrastructure system that manages the power grid in New Zealand. And so they moved this over to AWS Outpost and architected it with dual redundant AWS Direct Connects for network redundancy. And what this enabled them to do was to enable a zero-touch edge deployment with GDMS, GE ADMS, and it improved their outage management with near real-time geolocation of their electricity issues. So they're able to triage where they're having outages and address those during maintenance windows far more effectively. What it also provided them the benefit is they are also using the AWS region for these non-national infrastructure, right, non-latency sensitive workloads. And so they've now been able to have the same operations team manage their IT that's managing their OT, just building more efficiency into their overall operations. And then the last one I'll touch on is an announcement that was also made earlier this week at reInvent, but it's showing, again, the sort of pace that we're seeing customers take Outposts in to manage these business critical systems. And so this is POS X MES, which is a manufacturing execution system from Corber Pharma. And so they have validated their solution, which their end customers are pharmaceutical manufacturers, to manage their manufacturing environments. They validated on AWS Outposts for 2 different configurations that they're supporting with customers, with the pharmaceutical companies. The first is a multi-rack configuration, a multi-rack Outpost configuration, which does achieve a level of high availability and resiliency, while addresses some of the residency or data locality concerns and low latency requirements that this application has. The second architecture is deploying POS X MES on redundant Outposts. This will allow for a multi-site deployment for even higher even higher level of redundancy and resiliency. So if you look at the multi-rack Outpost deployment, here the redundancy is being handled at the Kubernetes control plane. So POS X is leveraging local Kubernetes control plane instances for improved orchestration and management across the multi-rack deployment. And then they're leveraging managed RDS on Outposts, and this is ensuring better seamless data handling and better data availability. And so the failover here is accomplished again through the Kubernetes cluster, and then these clusters are able to remain operational even during service link outages because they don't have a dependency on the region, and this ensures maximum uptime for this critical MES system. In the next architecture, this is the multiple Outposts. So this is the active-active architecture that they've deployed. And what this does is this takes full advantage of synchronous RDS replication for the databases. And so this ensures that there's data consistency and high availability between the 2 different sites or the 2 different Outpost deployments. And the active-active deployment also allows them to maintain continuous operations. So in the event that there could be a failure or an outage at one site, they'll fail over to the other site in an active-active fashion and ensures uptime for this critical system. So with the databases are always consistent and up to date due to the synchronous RDS replication being done on RDS on the Outposts, and manages data consistency. And then the failover again is being managed by the failover between the Outposts. And in this case, they can again lose an entire site. They can lose the Outpost. They can lose power or connectivity at that site. So all of these 2 architectures allow them to significantly enhance their ability to meet the needs for their reliability while still addressing low latency for the application. And thank you for your time. I'm going to hand it over to Pranav, and he's going to talk about local zones.
Thanks, Eric.
Thanks.
Hi. Hey everyone, I'm Pranav Chastra. I'm a Principal Product Manager at AWS. I've been working on local zones for the last 5 years. I, in fact, led the launch of US Local Zones in LA. And since then, I've been looking into what services we want to bring to these local zones and how do we want to improve the experience as well. So in this section, I'll talk about what local zones are, where are they available, what services are available in these local zones, and really then get into some of the examples of customers who are using these local zones to achieve low latency, either to their end users or to their on-premises installations. So before I dive deep into local zones, let's understand what local zones are. Logically speaking, you can think of these local zones as very similar to availability zones. It's just that they lie in a different physical geography. So what this means is that we as AWS have deployed infrastructure in these metropolitan areas, and these are what are local zones. We have connected these local zones to the region using our backbone connection, which is multiple redundant and secure connection. And what it does is that you can use services in the local zones, and because of the backbone, you can reach out to the region and use a lot of services back in the region as well. Similar to region, local zones also offer elastic on-demand pay-as-you-go pricing, which means that similar to regions, you also get the same operational and security posture that you expect and see in availability zones as well. So it's not a surprise that customers from many industries, including telecom, healthcare, manufacturing, gaming, and others, are using local zones to achieve what they want in this case, low latency either to their end users or to their on-premises installations. So before we get to the next set of slides, I want to basically discuss why do we even need local zones. So if you take this visual cue, let's imagine I am an end user who's a gamer in the Lagos metro area. As a gamer, I need to access a multiplayer gaming session, and the option in this case for me is the nearest region, which is the Cape Town region. And as a gamer, if I'm in Lagos and the region is in Cape Town, it means that the latency will depend on the traffic going from Lagos to the Cape Town, which is in tens of milliseconds, which of course is not ideal for a good gameplay experience. So we heard this feedback from a bunch of our customers, and what we did was we launched local zones across multiple metro areas, including Lagos in this case. So as an end user, as a gamer in Lagos, now I have a local zone available in the same metropolitan area, and now I can access the gaming server within single-digit millisecond latency. This of course provides the ideal experience from the latency perspective, which ensures that the latency is much more predictable and lower that customers expect in this case. So this is of course the distributed gaming use case. We'll get into some of the other use cases like hybrid, where customers are using local zones to reduce latencies to their on-premises installations or to their corporate assets as well. So the next question is, where are these local zones available? We launched our first local zones in LA in 2019, and then since then we've been adding local zones across the globe. So we have added over 16 local zones in the US, where the idea is to reduce the latency and make sure customers across the contiguous US can access low latency services within single-digit millisecond latency. And then we didn't stop just in the US. We of course expanded local zones internationally as well. We've launched over 15 local zones internationally in places like Copenhagen, Lagos, Muscat, Auckland, and Perth. And we've also announced some of the locations that you've seen in white here, which are over 10 locations where we're planning to launch local zones over the next couple of years, including Bogota, Hanoi, Athens, and so forth. Again, the intention here is that we want customers to get access to AWS infrastructure anywhere they want across the globe. So now that we've understood where local zones are available, let's understand what services are available in these local zones. So when we launch these local zones, we focus on bringing services where latency matters, which means that we brought services like EC2, EBS for block storage, ECS and EKS for our containers needs, and then some of the networking services like Route 53, Shield Standard, Direct Connect, and VPC. We've also had services like application migration service to help you migrate your workloads to local zones easily. And then we realized that as we added local zones in more locations, the use cases were unique depending on the locations we went into. So there are certain services that we've added in select locations depending on the use cases we saw. So the ones you see in white here, like FSX, NAT Gateway, RDS, GameLift, EMR, and Elasticache, these are services which are available in select locations, where the idea is that now we know how to bring these services to local zones, and depending on the feedback from customers, we want to bring these to more locations as we go. And as I mentioned, local zones are connected back to the parent region using our backbone connection, which means that beyond the local set of services that you see on the top, you can also access all the services back in the parent region, which means services like CloudTrail, CloudFormation, EC2 autoscaling, CloudWatch, S3, and so forth. They're all available in the parent region, and you can access them over the backbone from local zones. And in the last couple of years, we've heard feedback from customers that they want more capabilities across the set of services that we have added. So over the last year or so, we have added additional local zones in places like Atlanta, Chicago, Dallas, Houston, Miami, and so forth, where we have access to the latest generation instances, including Gen 6 and Gen 7. And we've also added more EBS volumes, including GP3, IO1, SE1, and then, of course, additional features like IPv6 and Spot instances that customers have been asking for. So these local zones are available in select locations, and then the idea is to evolve and add some of these capabilities into the existing metros as well as some of the newer locations where we're planning to launch local zones. So we just discussed that local zones is a logical extension of region, and that is also reflected in the pricing as well. There's of course no cost for enabling local zones. Once you enable local zones, the prices for EC2 instances and services running local zones are unique, so you can always find these prices on our pricing, the service pricing pages. And then there is, when it comes to data transfer, we think of local zones as very similar to availability zones and regions. So in this case, if you're trying to access S3 in the parent region from the EC2 running in the local zone, that is free of cost. And then beyond on demand, you can use savings plans. We've also had spot instances in some of the select locations for local zones. So before we jump into some of the examples of how customers are using local zones, let's discuss how it really works in practice. And I think from the experience perspective, you should really think of local zones as similar to availability zones. It's just that you need to first opt into these local zones. So you need to enable these for your own account. And once you do that, they show up alongside availability zones. And then you can extend your VPC by creating a subnet and linking into the local zone and start launching resources into it. So if you look at this architecture, this is a good example of how it really works in practice. So in this case, we have a VPC in US West Oregon, which is extended into the Seattle local zone by creating a subnet and linking into the Seattle local zone. And when we do that, all the things like gateways and route tables are automatically taken care of. And then because local zones have their own egress and ingress when it comes to internet and direct connect, you can access these local zones using your on-premise installations or from your end users with extremely low latency. And Direct Connect is an interesting use case where when we launched these local zones, we realized that a lot of customers were looking at these local zones as an extension of their own on-premises. So what they wanted to do was they would use Direct Connect to connect from their on-premise installations. It could be their own data centers, could be their co-location facilities, or could be their animation hubs or offices as well. And then they'll connect that on-premise installation to the Direct Connect location, which would then in turn be connected to the local zone, which is our infrastructure, through the virtual gateway. And when that's done, we've seen customers like Mindbody and others achieving as low latency as 1 to 2 milliseconds, which allows the hybrid architecture, which means that you can have some parts of your applications running on premises while you start migrating other applications to the local zone. So now that we have discussed how local zones are being used, I think another piece I want to touch upon is how do you really think about higher availability alongside low latency access here? And all in all, there are multiple options available here. So you can partition your applications between the local zone and one of the availability zones in the region, just like how you partition your applications between two availability zones in the region. So that's one option. And then we've seen customers partitioning their workloads between nearby local zones as well, for example, in Houston or in Dallas. And then there are locations where we have two local zones available in the same metro. That provides you the higher availability option here. And then finally, we have many customers like FanDuel who are partitioning their workloads between the local zone and the outpost to achieve the higher availability while ensuring low latency access here. All in all, there are multiple options here, and we do recommend you to work with your partner or AWS specialist to ensure that the architecture meets the requirements. So in the beginning of the presentation, Eric discussed various use cases for low latency, including multiplayer gaming. Now I'm going to provide a couple of examples where customers are using local zones to achieve low latency access either to their end users or to their on-premise installations, as well as what business impact local zones have been able to create. The first one is the example of Epic, where customers like Epic need to deploy the gaming servers in multiple locations so they can be closer to their end users. So in this case, when we launched our local zones in Dallas, Epic side using local zones in Dallas to achieve low latency access for the gamers who were on Fortnite, including in the US as well as some of the South America locations like Mexico here. And by doing that, Epic was able to ensure low latency access and the ideal gameplay experience, and in turn, by not maintaining their own data centers, they were able to scale up and down as and when they needed for their gamers and for their multiplayer gaming sessions here. The second example is the mind-body example, which goes back to the architecture that I was referring to, where there are customers like Mindbody who have told us that it can be daunting to move a portfolio of interdependent applications to the cloud. And what they do in this case is they would use local zones as a way to extend their on-premise installation. So they would use Direct Connect to connect to the local zones from their on-premises installation. And this in turn would enable hybrid architecture, which is what Mindbody did in this case. So they kept some applications on premises while they started moving other parts of the applications to the local zone while ensuring really low latency access within the same metro. And as a result, they didn't really need to refactor a lot of applications while they were able to move parts of the applications to the cloud here. Overall, both Mindbody and Epic are great examples of how customers are using local zones to achieve low latency access, either to their end users or to their on-premises installations. So now that we have covered both Outposts and local zones, I want to talk about how should you really think about choosing between the two options. And overall, it really depends on two factors: location where you want to run your compute and the latency profile that you want for your applications. So first of all, if there is a region available closer to you or your end users and that meets your latency requirements, we of course recommend regions that has access to a lot more services and scale. And then there are going to be locations where region doesn't really meet your latency requirements, and there is a local zone available closer to you or your end users, and that meets your latency needs. In this case, local zones are a great option. And then finally, there are scenarios where there is no region or local zone available that can meet your latency requirements. And in such scenarios, customers rely on Outposts. For example, manufacturing, where they really need to ensure ultra low latency, Outposts are a great solution in that case. And this is exactly what we've seen with customers like Riot and FanDuel, who are leveraging combination of both Outposts and local zones to bring their applications wherever they need it. With that, we've come to the end of the session. Thanks again for joining the session. Given this is a silent session, we will not be able to cover Q&A here, but both Eric and I'll be available outside to take any questions, and we are more than happy to connect offline as well and answer any questions. And then finally, don't forget to complete the session survey in your mobile app. Thank you.